Mesra Rule 2.2, there shall be no dead code. There is a subtle difference between a dead code from that of an unreachable code. And that difference is the following. An unreachable code is never executed. A dead code is a statement that is executed, but it has no effect on the program's behavior. So why is this dangerous? If it has no effect, then it should be okay, right? And you would be wrong there. Because by being there, it consumes instruction cycle, it delays program execution, it can cause, it can slow the program, it can prevent a for loop from being put into an instruction cache because of the presence of these instructions that are really not doing anything but consumes memory. It slows down a program, and there are a lot of nasty things that is caused by this presence of these instructions but has no effect on the program. These sections of dead code should be deleted, and so the Mesra rule flags this as violation. So, however, there is an exception to this rule. If a statement has no side effect, but then you want that to be declared as dead code, because by the way, if a dead code is sometimes removed by a compiler without your knowledge, okay, the compiler will remove it. See, so if you don't want that to happen, then the way to have an exemption to this rule is to cast it, to do a cast to void. So you're saying that, okay, this line is not doing anything, and by that it should be a dead code, but I don't want it to be a dead code. I want it to stay there, although it has no side effect. So you can cast it to void and it will not be classified as dead code. So let us go to an example. In this example, it is assumed that the object pointed to by P is used in other functions. Okay. Let us look at the first compliance statement. We cast B to void. This looks like a dead code because it's not doing anything. But like I said, we all agree that if you cast it to void, it's a mechanism to have as an exception to the rule. So this is our escape, guys. In all classifications, casting V to void has the characteristic of a dead code, but because we agree and because that is the rule, that casting it to void is an exemption to the rule. It's therefore not a dead code. It will not be flagged as a violation in Mesra standard. However, casting it to any other type, it will be non-compliant and will be flagged by Mesra as a violation. Next, shifting B 3 bits to the right is also a dead code. It does nothing. When you shift it to the right, then what's the purpose? Okay, what's the effect? If you delete it, the program still behaves the same, right? It's a dead code. It should not be here. Mesra should flag this statement as a violation. Like I said, presence of a dead code can slow down the program, can prevent a tight for loop from being put into an instruction cache, and it can cause a lot of alignment issues. So we should avoid dead code as much as possible. In fact, the compiler, if it detects a dead code, it will remove it without your knowledge. Next, x equals 3. This is also a dead code because x is never used subsequently down after that. It's a dead code. Next, asterisk p plus plus. The precedence here is the plus plus has a higher precedence. The pointer is incremented first, but then it returned the address before incrementing and references it. So the asterisk p is actually referencing the value of p pointed to originally, then the pointer is incremented. It has no side effect. Even if you remove this, the program still is the same. Nothing has changed. However, the one with parentheses asterisk p plus plus is not a dead code because whatever is the value pointed to by p is incremented, and this is a side effect. Other parts of the program will find it useful that p is incremented. It has a purpose, and therefore it's not a dead code. In the following compliant example, the ASM keyword is a language extension, not a function operation, and is therefore not a dead code. So it is not doing anything, the new NOP operation. However, NOP operation has special purpose. First, it introduces a delay into a program's execution. Second, it can be used to align instructions in memory. Third, you can put a block of NOP instruction for the purposes of putting actual assembly code instructions in that area later on. So some sort of self-modifying program. So in the following example, the function g does not contain dead code. However, the call to the function is a dead code. So I highlighted here first the function, and the second that I highlighted is the call to the function. So the function is not a dead code, but the call to the function is a dead code. So that's it. So okay, lastly, I will say, why is it that G is not dead code when there's no effect? Well, you can declare a function with empty implementation, right? Because later on you might put an implementation there, and that is why G of the function G in declaration is not a dead code. But once you call it, then it will be flagged by Mesra standard. That is all for now, and we differentiated a dead code versus an enrichable code, and then we also explained the different contexts in which a dead code is seen as or is flagged as a violation, and we saw a mechanism for exemption using a cast to void. That's all for today, guys. Thank you.